Okay, so this is unit test 3, questions 11 through 15 here. And on these questions, if you look at our item analysis on this, um, question 11 came in below 60%. And again, this was similar to a question we earlier in the test. We put two of them in here just to see what would happen. It was very similar to question number 7. A little bit better success rate on question number 11. Um, but again, what we think happened to a lot of people is when you solve this, you end up with two answers. And one of those answers does not check. It's not a legitimate answer. And again, it comes down to seeing structure. Pretty good results for number 12. People seem to be getting the hang of the fractional exponents here. This was a little different because you had to factor out an exponent and then everything went to integers, so it got a little bit easier, maybe. Um, but that's coming along. Um, the complete the square method, we detailed that question in on question number 6 from the previous video. So we'll do number 13 here and take another look at this complete the square method. See if you can understand the algorithm for how you do this question. All right. Now the other thing we saw as we ran through these later questions is the number of people responding was dropping off. Right. We had about 120 some odd people take this, and you can see we had a number of no responses here as we got into these later questions. Um, question 14 got irrational expressions, not a simple proportion though. It got a little more complicated there. So we'll look at that. And 15, again, a radical expression, possibility you'd get two answers and not reject one of the answers. So with that, we'll get going on this and look at number 11 here. This is the radical equation. So we isolate the radical, right, by bringing the 1 from the right-hand member over the left-hand member, and then we square both sides, right? So that gets us to an x plus 5 here on the right. And when you square x minus 1, you multiply x minus 1 times itself, you get x squared minus 2x plus 1. You see the quadratic, and so you think get one side to 0. So we move the x and we move the 5. And we get x squared minus 3x minus 4 equals 0. And then that is super easy to factor. That's elementary algebra. You get x minus 4, you get x plus 1. You set each one of those factors to 0, and you get x equals 4, and you get x equals minus 1. And then out of that, what you find is the x equals minus 1 does not work, right? Because if x is negative, this side is negative. And structurally, you've got a negative number, right? Got a negative 1 right there. And you've got a plus 1 over here on the right, and you're adding some more to it. So there's no way they can be equal, all right? So the only answer was x equals 4 to that situation. Number 12, pretty good success rate here. You have a common variable. The rule on variables is you factor out the lowest power you see. You divide out the lowest power you see. And when you do that, you want to look at what's left there, right? So on that question, let me just refresh this. We've got a 71% success rate, so doing pretty well with this. Um, from there, divide out x to the 1/3. So you subtract the exponents, right? When you divide numbers with the same base, you subtract the exponents. This becomes x to the 6/3, which is x squared, minus 8. X to the 4/3 divided by x to the 1/3 is x to the 3/3, so that's x to the first. And then, of course, the 12x to the 1/3, divide out the x to the 1/3, that's a multiple of 1. So that becomes a simple 12. Okay? From there, we get x to the 1/3 x minus 6, and x minus 2 equals 0, right? Then set each one of those factors to equal 0. X minus 2 equals 0 gives us x equals 2. X minus 6 equals 0 gives us x equals 6. Okay? And x to the 1/3 power equals 0 gives us x equals 0. And that's okay. So all three of those answers are keepers. You can have a cube root of 2. You can have a cube root of 6. And of course, the 0 is acceptable. That's a variable equals 0. That's fine. It's when you end up with a solution where you have a constant, a number, right, equals to 0. That's when you reject that situation. There were a number of people that only had the 6 and the 2. They didn't. They lost the 0 when they were doing their factoring. They lost that variable, and that's what seemed to cause the problem there. 13, we asked that you do this by complete the square. So we won't go through all the bullet points like we did in the video for the previous question, but we'll mention them. You force A to be 1. Okay, now the 2/8 I'm going to reduce to 1/4. Okay, and you remove the constant to the 0 side. So that's going to be a 3/8 over there, and I left a hole right there, right? Now, you factor by splitting B. You factor by splitting B. Okay, so we factor by splitting B, which means B is 1/4. So it's going to be plus and plus because you want them to be the same, right? And half of 1/4 is 1/8. It's this simple. When you split that B, all you have to do is double the denominator. The denominator is a 4, so you double it to an 8. Now, the next bullet point, you square back to fill that hole. So you're going to add back in 1/64th. And that's based on the FOIL idea from elementary algebra. You know you're going to get the x squared. You planned it that way. By doing an outer pair of 1/8 x and an inner pair of 1/8 x, you get 1/4 x. All right? And then, of course, the last terms, FOIL, F-O-I-L, 1/8 times 1/8 is 1/64th. We're going to add that over here too. Okay? So we add it over there like that. Now, in order to actually add these things, they have to be a common denominator. You can't just add them like they are. They have to be the same denominator to add fractions. So this is going to be 24/64ths, right, by multiplying top and bottom by 8 to get the common denominator, plus 1/64th. You've got 25/64ths. Okay? And then here, of course, we have what we're going for. We have a square. We have x plus 1/8 squared, right? Then from there, we do our square root, and we get x plus 1/8 equals plus or minus, and this is actually a perfect square, 5/4. Okay, so plus or minus 5/4. Sorry, 5/8. 5/8, not 5/4. 25/64 square root is 5/8. Bring the 1/8 over, put it in front, and you have two answers: 1/8 plus 5/8 and 1/8 minus 5/8. Well, that of course obviously is 6/8. Probably should be reduced, right? To what? 3/4. So one answer, 3/4, and the other answer is -4/8, because 1 minus 5 is -4, which is -1/2. Okay? So there's the solution for number 13. Two answers, 3/4 and -1/2, done by the complete the square method. Okay. Now, the fact that the square root went completely away, right? What that tells you is that this actually could have been factored. You could have done this by AC method and it would have factored. So that's that question. Now, from here, we'll go to this number 14, and things kind of slid a little bit here on this question 14. Rational expressions set equal to each other. But instead of being like the one that was easier earlier on in this test, it wasn't a proportion this time. All right. What I'm going to do is create a proportion. Okay, I'll create a proportion, and we're going to do that by changing the 1, right, into a y minus 3. Okay, change the 1 to a y minus 3. Well, how am I going to do that? Well, remember, 1 is a chameleon. It can look any way you want it to look. And I want it to look like y minus 3 over y minus 3, because that way I have a common denominator here with the other term that's on the left. Not doing anything with the right. Okay. And then when I combine those, 5 plus y minus 3 is going to turn out to be who? Y plus 2, y minus 3, 30. Okay. Now, can be an advantage here if you think to do something. You can make life a little bit simpler here if you see the structure. Okay. We actually have a proportion we could cross multiply if we wanted to. But instead of doing that, what I'm going to do is create equal denominators on the left member and the right member. Okay? So I hope you can see that if I just multiply by y plus 3, top and bottom on the left, okay, then that will give me the same denominator that I have on the right. And when I FOIL these numerators together, I'm going to get y squared plus 5y plus 6. And of course, it's over that common y plus 3, y minus 3. And on the right, I have 30 over y minus 3 times y plus 3. Now, you've got equal denominators. The two denominators are now identical. The fractions as wholes we know are equal. So if the denominators are the same, and if the fractions as wholes are equal, then don't we know that y squared plus 5y plus 6 has to equal 30? All right? So rather than use the proportion concept and cross multiply, right? Instead, I opted to create the same denominator, and then once I have matching denominators, I know that my numerators must match. From here, you're quadratic, so you get one side to 0, and you're pretty much in elementary algebra, right? Because this is going to be y plus 8, and it's going to be y minus 3, right? And then out of that, y minus 3 equals 0, and y plus 8 equals 0, which gives me y equals negative 8, and gives me y equals 3, right? So you go to the WebAssign answer box, you enter a negative 8, a comma, and a 3, and it gives you a big red X. Why? Again, and I didn't mention it at the very beginning on purpose, but it should be apparent, right? What's 3 minus 3? What's 3 squared minus 9? Division by 0. So that 3 had to be excluded. So we want you to see we're purposely giving you problems where there might be an issue of a denominator being a 0 or a radical square root going negative on you. or other times where you have a radical and it's a cube root and it can be negative. So these are the kinds of things we're trying to refresh your memory on from the high school realm so you're ready to hit the ground running in the fall. Okay. Last one, 15. It'll only take a minute here. Dealing with a radical equation. The radical is pretty much isolated. It has a 2 multiplied by it, but I'm going to square the entire side in number 15. So what I'm doing, of course, over here, I'm doing this, and over here, I'm doing that. So I'm doing 2 square root of x times 2 square root of x. Well, it should be pretty apparent that that's 4x because you're squaring the square root, right? So that's where I'm getting that 4x from. Bring the 4x over and subtract it, okay? And we get x squared minus 10x plus 9 equals 0. That factors into an x minus 9 and x minus 1. Okay. And then each of those set equal to 0 gives me a solution of x equals 9 and x equals 1. Okay. And guess what? In the original expression, which was this, the 1 is not going to check. The 1 is not going to work because 1 minus 3 is negative 2. And does that equal 2 times the square root of 1? Square root of 1 is 1. 2 times 1 is 2. Does negative 2 equal 2? No. So the 1 gets rejected. Number 15, the only answer was 9. Okay? So that's 11 through 15. As always, if you got more questions or you need more help with something, do not hesitate to call us and we'll see if we can help you out.